Alright, moving on to question 38. Mary wanted to find out if the presence of substance A will affect the degree of transparency of a liquid. She prepared the following setup using 400 ml of liquid X and conducted the experiment in the dark room as shown below. Okay, so from this question, let's do a bit of highlighting. So you want to know whether or not presence of substance A will affect the degree of transparency. Okay. Then the question then goes on to ask you, describe how Mary should prepare a control setup for the experiment. So once again, whenever there's an experiment, it's always good to identify what is your change variable. And then after that, and what is your measured variable. So in this case, the measured variable is not very clear. Right, they didn't exactly state what is it. They only state they wanted to find out what's the degree of transparency. And how can you measure that? They use a light sensor instead. So your measured variable would, you need to figure out that from your light sensor, you're looking at the amount of light detected by light sensor. And in this case, the higher the amount of light detected by the light sensor, the more transparent it is. Okay? So remember, in a control setup, I have mentioned this before. C stands for change variable. And in a control setup, you want to remove away this change variable. So basically, it would be to have an identical setup, except that there is no change variable. So how would the answer look like? Prepare the same setup but without substance A. And that's about it. B. Explain why Mary conducted the experiment in a dark room. So this is actually talking about fair tests. It's a fair test question whereby you want to ensure that there's only one change variable. And the change variable is substance A. So you want to conduct it in a dark room so that your amount of light only comes from your torch and nowhere else, and not from your surrounding. Okay, so this will help ensure that it is a fair test. But in this case, you need to be specific. You cannot just say, oh, it is to ensure that it's a fair test. You need to identify which constant, which variable that you're trying to keep constant. So in this case, it is the light that you want to keep constant, right? So the answer would be, this is to ensure that light sensor only detects light from the torch. And not from the surrounding. Okay. Next, Mary wanted to compare how the presence of different substances would affect the degree of transparency of a liquid. So highlight keyword, different substances, and degree of transparency. So essentially this is your change variable, and this is your measured variable. She repeated the experiment by replacing substance A with B using 400 liquid of liquid Y instead. Her classmate commented that it was not a fair test. Do you agree? So once again, fair test, there can only be one change variable, right? So, and the change variable in this case would be a presence of different substances, and that is your A and your B. So therefore, it's very important to ensure that no other variables are changed. So let's take a look. Initially, what's the amount of liquid X used? So the amount of liquid X used is 400. And they are also using 400 ml of liquid Y. So in this case, I would say that this is actually not a fair test. Okay, reason being that there should only be one change variable, but in this case, you used liquid Y instead of liquid X. So because of that, there is actually two change variable. One change variable is the presence of different substances. Another change variable is that you use substance Y instead of X. So therefore, the answer would be, you should agree with a classmate. Okay, and then after that, explain that there is more than one change variable. So how would the answer look like? Agree as changing the liquid used would affect the amount of light detected by the light sensor. Hence, she should use liquid X for both setup and change the substance used to ensure that any change in the amount or the amount of transparency is due solely to the different types of substances. Alright. Okay, moving on. Question 39. Ben could not open the glass jar with a tight lid. Hence, he placed the jar into a tub of hot water as shown below. After 5 minutes, Ben still could not open the glass jar. Without using different apparatus, or additional materials, suggest what Ben could do in order to open the glass jar. Okay, so first things first, it's always good to identify what is the topic. So the topic of this question is obviously on heat, and the concept that they are testing you on based on what my understanding would be on expansion, right, and contraction actually. So in this case, they show you that they did that this setup, but Ben could still not open the glass jar. So obviously, what happens is that Ben is trying to use the concept of expansion to try and help him open up the glass jar. So when you look at this setup initially, true, but you see, the whole idea is you want to get the metal lid to be bigger while you want to shrink your glass jar, right? Only then can you open up the lid. But what he has done over here by putting the whole glass jar in is that he has expanded, okay, and made your glass jar bigger. You realize that because this portion, which is in contact with the hot water, would have gained heat faster and expanded faster than your metal lid that is not touching the hot water. So in this case, he's making it even worse. You realize that he is making your glass jar bigger, okay, while not while your metal lid remains the same size. So in this case, he actually makes it tighter. Okay, so what he should have done is to flip the glass jar over. Okay, flip the glass jar over such that now the lid is submerged inside the water. And only the lid. So now only the lid would gain heat and expand. This would cause your lid to become bigger than your glass jar. Okay? So how should your answer look like? Okay, Ben should flip the jar and immerse only the metal lid into the hot water. Okay? Okay, so explain your answer. Okay, by immersing the lid into the water, hot water, the metal lid gained heat faster than the glass jar. Okay, sorry, can I just add one point here? As gain heat faster and expanded faster than the glass jar. As such, the lid loosens, or maybe we should, hold on, can I just change this part? Okay, the lid becomes bigger than the glass jar, and Ben can open it easily. Alright, so a few things to note here. First, you need to tell me that the metal lid gain heat from where? Sorry, yes, I forgot this part. From the hot water. Okay, and then it expanded, and then you to tell me that it becomes bigger. As such, he can then open it easily. Alright, pick two identical metal cups. Two identical metal cups were stuck together and needed to be separated. Put a tick in the correct boxes to indicate which of the following are needed. So when you have two cups like this and they didn't tell you, it's good that you draw it out so that you know what is happening. So you want the inner cup to this inner cup, this is A and this is B. Okay, so you want the inner cup to become smaller, so you could put the ice cube inside, right? But you want the outer cup, the B cup, to become bigger. So you need some sort of what do you call it? Like a source of heat, right? So then you will put hot water on the outside. So therefore the answer would be ice cube and hot water, these two. Alright, moving on. Question 40. Tom and Judy prepared identical hot moist towels A and B respectively to welcome hotel guests. Tom rolled up the towels while Judy laid towels B flat as shown. 5 minutes later, Tom observed that the towel from the top of the stack of B was much cooler than the one that is rolled up on top of towels A. Explain the observation. So in this case, firstly, it's good to actually once again identify the topic that's being tested and then make annotation, especially with questions like this. Complicated question, experimental questions, they are usually looking at fundamental concepts. Okay, but in order for you to identify these fundamental concepts, you have to annotate. If not, it's going to get very messy. So the first thing that I notice is that the topic that they are probably testing me on is on heat. And the concept here they are testing me is rate of heat transfer. Right? And if I'm experienced enough, straight away I'll be able to realize that it's talking about your surface area exposed. So if you look at these two, I always tell you all need to compare. What is the difference between these two? The rolled up one and then versus the layout strip. So right off the top, you realize that for A, there is less exposed surface area as compared to B, which is more exposed surface area. So if you look at the question, it talks about the fact that he noticed that B was much cooler. So you're looking at temperature, right? And temperature has got to do with heat gain or heat loss. So in this case, they tell you that B has a lower temperature. So a bigger lower arrow as compared to A. smaller arrow. Okay, so this is the two main difference. So obviously you probably need to account for why is that happening. So then you look at what is difference between the both of them. So you will realize that for B, because they are more exposed surface area, rate of heat loss is actually faster as compared to A, okay, due to the lesser exposed surface area. So because of that, you then have a lower temperature due to faster rate of heat loss due to the more exposed surface area. So in question like this, it's good to sometimes do a reverse engineering, whereby you ask yourself, how come the temperature will go down? Oh, because rate of heat loss is faster. How come the rate of heat loss is faster? Because more exposed surface area as compared to A. So with that, then you know that all these points needs to be inside your answer. So let's see how is the answer crafted. So tower B has a greater exposed surface area to tower A. Okay, wait, hold on, can I just change this a bit to make this more perfect to the surrounding air. Surrounding air compared to A. Okay, hence B loses heat faster to the, sorry, just one second, loses heat faster to the surrounding, to the cooler surrounding air. So in this question, there's a few things to note. Firstly, it must be comparative. So greater exposed surface area. So remember your superlatives. Okay, and then you must tell me exposed surface area to what? So to your surrounding air compared to A. And then you have to tell me that it lost heat faster. Once again, superlative. Okay, so I'm going to highlight the superlative word because these are the things that we tend to be more careless. Okay, lost heat from where to where, gain heat from where to where. So make sure you tell me that lost heat to the cooler surrounding. Okay, moving on. To keep the hot, moist towers A hot, Judy suggested storing them in a covered box before distributing to the guests. They put towers A in two different boxes made of metal and wood respectively. Okay, as shown below. They measured the temperature of the towers A in the boxes after 15 minutes. Okay, even without really looking at the next question, I roughly could guess what are they going to ask me and what are they testing me on. So because I have these two different materials, metal and wood. So straight off the top, I know that this question, they are really testing me on the concept of conductors of heat. So when you're testing on conductors of heat, right, I've said this many times, you're really concerned about the rate of heat transfer. So if you recall, something that is a good conductor of heat will allow heat to pass through it very quickly, such as metal. Okay, and something that is a poor conductor of heat will not allow heat to pass through it quickly. Okay, so in this case, the first thing we need to do is we need to ask ourselves, okay, where is the hotter region and where is the cooler region. So in the diagram, you realize that because these are hot, I will assume that this has a higher temperature as compared to the surrounding outside air. So remember, heat always gets transferred from a region of higher temperature to a region of lower temperature. So it's going to be lost to the surrounding, and therefore your temperature will go down for both boxes. Now the difference is that your metal box over here is a good conductor of heat. Okay, whereas your wooden box here is a poor conductor of heat. Okay, now I would say that when you talk about conductors, right, it's also good to use superlative. Alright, so if you want to talk about the wooden box, you need to say, oh, it is a poorer conductor of heat as compared to metal box. Try not to say that, you know, one is a good conductor and one is a poor conductor, especially if they are the same type of material. Let's just say copper and iron. They're practically both metal. So it's hard to say things like, oh, you know, one is poor and one is good. You should say one is a better conductor of heat than the other. Okay, because actually they are both good conductors, right? Okay, this is one other thing I would like to point out. So anyway, before even looking at the question, I would know that my wooden box, okay, the temperature should be higher. Okay, when I compare this to my metal box. Why? Because heat can be lost at a faster rate for my metal box because it's a better conductor compared to my wooden box. So because it is a poorer conductor, heat will be lost at a much slower rate, okay, for my wooden box, therefore retaining more heat and your temperature will be higher. So let's look at what the question is asking. Okay, they recorded the results in a table below, okay, and then they ask you to predict which box is which box, right? Okay, so like I told you, the one with the higher temperature after 15 minutes should be your wooden box, and then the one that is of a lower temperature is your metal box. So can you see how actually understanding the question even before reading the question sometimes can help you make better sense of and better anticipation of what the question is asking you. Based on the information, okay, we have done this. Explain your answer in B, okay, which is this. Okay, so there is two way of answering this. Is either you talk about the metal box or you talk about your wooden box. All right, okay, oh sorry, actually you have to talk about both metal and wooden box. You need to explain why. So let's talk about the first one, which is A. Okay, so I'm going to explain it and just pen it down in words because I did explain to you previously why. Okay, so the temperature of A in the metal box would be lower as metal is a better conductor of heat than wood. Hence, the tower in the metal box would lose heat at a faster rate compared lose heat. We need to put in one extra point here to the surrounding. Okay, remember this, very important. Okay, heat loss from where to where. Okay, we can continue after that. A faster rate compared to the tower in the wooden box. Okay, so you need to talk about it being a better conductor, you need to compare, and then you need to talk about where heat is being lost, and then you need to talk about the faster rate. Okay. Okay, 41. Right off the top, when I see this kind of question and I see this flow diagram, I already know that this is talking about forces probably. Now, right off the top, even before I attempt this question, I will actually start to recall what my teacher has told me about this kind of question. So this kind of question, right? Anything with a verb in it, okay? Turning, moving, spinning, twirling, alright? Action words probably 99.999% is going to be kinetic energy. Alright? So with that, I straight off already know that my falling water and my spinning water wheel, okay, is going to be kinetic energy even without reading the question at all. So let's jump right into it. Gabby prepared a setup as shown below. Okay, you've got retort stand, you've got water, you've got spinning water wheel, you've got generator, you've got light bulb. So basically how this setup work is your water will flow down, spin the wheel, and then after that your generator would generate electricity and then to power your bulb. Very straightforward actually. So the water in your container A, okay, is at a height, right? So because there is height, this is GPE. Okay. Sorry, did I say forces earlier? Okay. My apologies. I meant energy conversion. Yeah. Let me just correct myself on that. Energy conversion. Okay. So your GPE would then be converted to kinetic, like I told you, because of the word falling, and then because of the word spinning, it is still kinetic, no change. It's just different form of kinetic energy, which then goes to your generator. Now your generator is actually electrical. Okay. And then after it, from your electrical, your light would produce light energy, right? Your light bulb, sorry, I meant. Now, whenever you have this kind of question, do note that the next few questions are, whatever it is, you are going to need to use this to help you formulate your answers, probably, especially when they ask you to describe how, certain conversion, how okay, you're going to need to use this to help you to craft the following answers for the following questions, because probably they're going to ask you about how the change of one type of energy is going to affect the rest. Water was splashing off the water wheel and making a mess. So Gabby adjusted the retort stand to lower the spout of the container A closer to the water wheel. So what it means is that she brought down this whole area, this whole part downwards, lower it. Okay? She noticed that the water wheel was still spinning, but the light bulb became dimmer. So light bulb dimmer was still spinning, okay, and then she lowered it, right? So what does all this thing mean? So very straightforward. Actually, this is a very straightforward question. When you lower your contraction here, you're actually lowering your water, which lowers your GPE, right? So with lesser GPE, lesser GPE to be converted to lesser kinetic energy of your falling water, which results in lesser kinetic energy of a spinning wheel, and then lesser electrical energy, which means that your bulb now produces or gives off less light, and therefore it became dimmer. So can you see it's really directly related, and all you have to do is to tell me where is the chain reaction, where was affected, and how did it first get affected. So the part that it got first affected is the decrease in your GPE. Okay, so you need to explain how does lowering affects your GPE. So you say lowering container A there would be less GPE, gravitational potential energy. Please spell that in full. I'm just saving time of the water. Now you need to tell me, this is very important, okay? Who does this GPE belong to? You cannot just say less GPE. You must say GPE of what? Is it of the spinning wheel, of the generator, of the falling water? So you have to say GPE of the water. You need to be specific like that, okay? In container A. To be converted to less kinetic energy of the falling water, which was converted to less kinetic energy of spinning wheel, then converted to less electrical energy. Of the generator which then converts to less light energy of the bulb. So can you see we're really just going through the whole description of the various types of energy, right? And throughout the whole thing, it's very important to put your superlative. So you have less, and less. Okay, so something that is very common, but you have to do it. Alright, so this question is not difficult. Alright, thank you for